Sorry about that, guys. I ran out of time. Okay. Getting back to where I was. Okay. So sodium, as I was saying, is the electron configuration of neon plus that 3s1 electron. Well, sodium we know forms a positive 1 charge, which means that it has that extra electron and it loses that extra electron. So when it forms a positive 1 charge, this electron right here gets lost, and therefore its electron configuration would be that identical of neon's. Magnesium, which is in the next row going over, it's element 12, it forms a positive 2 charge. This is the atom of magnesium, neutral magnesium. This is its electron configuration, neon plus 3s2. When it forms that positive 2 charge, it loses 2 electrons, again making it identical to neon. Aluminum does the same thing, forms a positive 3 charge, removing its extra 3 electrons and making it once more just like neon. The same thing happens on the other end of the spectrum, where if you start with oxygen, oxygen is heliums with 2s2 and 2p4, which means it has a total of 6 valence electrons as its normal state. But oxygen forms a negative 2 charge, meaning it gains 2 electrons. So if you gain 2 electrons, that would make it equal to neon, because that would be 2p8, which is the same as neon's configuration. Fluorine the same way. Fluorine normally is 2s2, 2p5 after helium, but it gains 1 extra electron, making it that 2p6, which is the same as neon. So it has 2 plus 6 is 8, 2 plus 6 is 8 valence electrons. You get that of neon. All right, there is one last piece to talk about today, and this will get reviewed again in the next set, which is also just first of all looking at, well, I guess there's two more things. Understanding what these things are going to look like. So here we have the characteristics of ions and ionic compounds. So ions packed together maximize all of those tractions between ions. It's going to be very tightly packed, creating a sort of very strict structure as it goes together. When you have polyatomic ions, they work the same way, but covalent bonds are what's actually holding together those bonds within the polyatomic ion itself, so it behaves as a unit. In H4, the nitrogen and the hydrogen are not ionically bonded together, they are covalently bonded together, and then as a covalent unit, they then form an ionic compound. So anything that has those polyatomics is going to have multiple bonds happening. This is the last thing that we're going to talk about today that we will then talk about again on the next set of notes, and that is that when things change into their ionic form, the size of their radius also changes. So cations, when they're losing an electron, are going to get much smaller because you're taking an electron out of that shell, so therefore there is less distance between the nucleus and the outside point of the atom or the ion. And anions, when they're gaining electrons, are going to get bigger because now you're adding electrons onto that shell and you're widening it. So the big thing to take away here, cations are always going to be smaller, and then anions are always going to get bigger, which makes sense. Cations, you're taking something away. Anions, you're adding something. So when you add something, it gets bigger. When you take something away, it gets smaller. All right, that's it. Have a good night.